Hello everyone. Today we are going to learn about lime together. Before learning lime, let's first understand the relevant concepts of cementitious materials. Firstly, inorganic cementitious materials are divided into air-hardening cementitious materials and hydraulic cementitious materials. Air-hardening cementitious materials can only harden, retain, or develop strength in the air. Commonly used materials include lime, gypsum, and sodium silicate. Hydraulic cementitious materials can harden in air and better in water, retain and develop strength, for example, all kinds of cement. In this lesson, I'll introduce lime and its technical properties. And there are three aspects: the lime production, its variety, and its slaking and hardening. First of all, let's learn the lime production. The main raw materials for lime production include limestone, dolomite, chalk, shell, etc. They mainly provide the needed calcium carbonate. The main lime production process is calcination, which decomposes CaCO3 into CaO plus CO2 at a temperature of 900 to 1200 degrees Celsius, and the CaO is quicklime. When there is a low calcination temperature, insufficient time, or large raw materials, the lime produced is underburnt lime, characterized by normal calcined lime on the outside, with underburnt core left. Underburnt lime has a low utilization rate and poor bonding ability. When there are too high calcination temperatures or a long time, the lime produced is overburnt lime, characterized by cracks or glass-like shells on the surface, obvious volume shrinkage, and grayish-black color. The overburnt lime hardens slowly. The volume expands after hardening, easy to cause bulging and cracking. Second, let's learn about the varieties of lime. Commonly used lime varieties in buildings include blocky quicklime powder, hydrate lime powder, and lime putty. Blocky quicklime is ground into quicklime powders. Quicklime is digested with an appropriate amount of water, and hydrate lime powder is obtained after drying. The main component is CaOH2, also known as slaked lime. Quicklime is digested with excess water to obtain lime putty. Please think about a question. Slaked lime is digested with an appropriate amount of water, while lime putty is digested with an excessive amount of water. Then, can lime putty be obtained by mixing slaked lime with water? Of course. Third, let's learn the slaking and hardening of lime. 1. Slaking of lime. Slaking of lime refers to the process that when lime is used on the construction site, quicklime is usually added with water to digest it into slaked lime, that is, calcium hydroxide. The chemical equation is: calcium oxide reacts with water to form calcium hydroxide while releasing a certain amount of heat. It can be seen from the chemical equation and picture that lime slaking has the characteristics of volume expansion, releasing a large amount of heat and fast reaction speed. As we have just mentioned, the overburnt lime slakes slowly and expands in volume after hardening, easy to cause bulging and cracking. To eliminate the harm of the overburnt lime, the lime slurry formed by slaking quicklime should be placed in the lime storage pit for over 2 weeks to fully slake the overburnt lime. This process is called aging of lime. During this period, a layer of moisture shall be kept on the surface of the lime slurry to prevent carbonation by excluding airborne carbon dioxide and slaked lime. What is the carbonation specifically? Next, let's talk about the hardening of lime. 2. Hardening of lime. The lime slurry gradually hardens in the air, which is completed by crystallization and carbonation simultaneously. Crystallization. Free water evaporates or is absorbed by masonry. CaOH2 precipitates in crystal form, and the slurry gradually loses plasticity. The crystallization is characterized by the development from inside to outside. Carbonation. CaOH2 and CO2 in the air combine with water to generate CaCO3 crystal. During this process, moisture is released and evaporates eventually. Carbonation is the reaction of carbon dioxide with water to form carbonic acid, which then reacts with calcium hydroxide to produce calcium carbonate. So this cannot be done without water or carbon dioxide. Since airborne carbon dioxide first contacts with the surface, the characteristic of the carbonation is just opposite to crystallization, which is from the surface to the inside. 3. Characteristics of hardening. First, as we have just learned, the crystallization is from inside to outside, and the carbonation is from outside to inside. Second, due to the low concentration of airborne, the carbonization is slow and usually takes several weeks. Third, a large amount of water is lost in the crystallization and carbonization, resulting in large volume shrinkage and easy-to-produce shrinkage cracks. It can be seen that lime is an air-hardening cementitious material with slow hardening and low strength. Through the study of lime and its technical properties, please think about and discuss a question after class. The following 2 pictures show lime slurry A and lime slurry B. What is the difference between the cracks caused by the 2 hardened lime mortars? What are the causes? I'll tell you the answer in class. That's all for this lesson. Thank you.